Wadsworth, founder and CEO of DorothyAI. Today we're going to be focusing on novelty, and what I would like to show you is what happens when you weight a query differently. So we'll get into how to create a good query, as well as what weighting ultimately does and how these results compare to Boolean type searching. We'll begin by creating a project where we can store all of our training videos. It's just a basic form that includes some information about the type of searches that we're going to be doing, as well as some information about the client. We're not using this information right now. We will be using it when we launch our alignment product. Alignment is available as a service right now. Check it out on our website. Once we click create, that will take us to our projects page where we can store all the searches that we're doing in one place. For the searches we're going to be doing today, we're going to use this patent as the source document. In particular, we're going to be looking for metal air battery cathodes that have some amount of porosity. If we look at the issued claims of this patent, what we'll see is that the final wherein clause includes a description of a three-dimensional network with a specific range of porosity. That is the element that we're most interested in looking at throughout this series of searches. All right, the next step is simply to click the new search button. We'll click novelty, and this will provide a modal where we can input our search query. For the first search, we're just going to simply take that wherein clause that we just looked at, add that it is part of a cathode for a metal to air battery, and use that as our abstract. We're then going to take that exact same text and use it as our novel feature. So for the first search, we're using a very short description of the invention in the abstract with an identical novel feature. We're going to leave the weighting at medium right now, which is the default. So once we have that information, we can hit next. It'll ask us if we want to continue. We hit yes, and now we're back to the projects page. So for the second search we're going to do on the same subject matter, we're going to use the entire abstract from our search patent as the description of invention. We're going to use the exact same novel feature that we used in the first search as the novel feature in the second. So the only difference between the first search that we're performing and the second search that we're performing is the amount of information in the abstract description of the invention. We're going to run one more search. And in this search, we're going to use a little bit more information. It's going to go back to the source document, copy and paste the background of the invention, which includes more information on metal to air batteries, as well as information about the three-dimensional networks and why porosity is important. We'll use that information along with the abstract that we used in the second search as our description of the invention, and then we're going to use the novel feature that we used in the first and second query. So the novel feature in all three of these queries are identical. The only difference is the amount of information that we're including in the description of the invention or abstract. Now we're back on the projects page, and we can see that our first and second searches have now returned. If we click on the first search, we'll take a quick look at some of the results just to get an idea of whether or not we're on track or not. So as we scroll through the first set of results, the first thing we note is that the source document is being returned at number 1. So we have matched the text from the query to that specific reference, even though we modified the text slightly. As we scroll through the remaining results, what we're seeing is a lot of references that describe metal to air batteries. Looking strictly at the title, this gives us a good idea that we're pretty much on track. But we can look at some of the key phrases that are returned as well to get a better idea of whether or not those references are good. We'll go back to the projects page and do the same thing for the second set of references. Again, we see the source document is returned as the first document in the search, and the remaining results are similar, most of which are describing metal to air batteries based strictly on the title. So it seems like we're in a pretty good position on this search as well. So we look at our third search. We see again that the source document is number one. Here we have a lot of text to compare, so it makes sense that it would identify that reference as the first reference here. And as we scroll through, we're seeing more metal to air batteries and fewer of some of the other references that we saw creeping in the other searches. Overall, the results from all of the searches that we tried look pretty good. So the next thing we're going to do is we're going to make some very simple modifications to this query and look at what it does to the final results. First, we're going to go back to that initial search where we had the short abstract and a matching novel feature. If we click that refine search button, what we'll see is we get the opportunity to make any modification we want. In this case, what we're going to do is we are going to click on weight and move that weight to high. Do the exact same thing for each of the searches that we have tried. So the abstract only with the same novel feature, we are going to weight that at high and then hit next so we can get that search underway. And then finally, we're going to do the same thing with the background and abstract. Perform the search, and there we go. We'll give those a few minutes to cook and talk about how we're going to actually compare these searches. So searches are kind of subjective. You either like the results or you don't, and you try something else. What we're trying to do is find a more objective way of understanding whether or not those results include what we're looking for. A good way to do that is using concepts. Let's take a look at our first test. Feature weight at medium. We have the abstract and novel feature are the same, and they're very short. We have the short abstract and we have the long abstract. Then we have the total number of results that come back. The number of those results that include a description of porous material, the number of those that come in the top 10, and the number of those results that appear in the top 100 results. And what you'll see is that we are pulling quite a few references, even with a very brief and short novel feature. We're pulling, 3 out of 10, which isn't really bad if you start looking at Boolean numbers. And about 25% of the top 10 includes these patents that discuss porous material. It gets a little bit better with the short abstract. The long abstract, however, with a little bit more background information that gives the back-end search functionality a little bit more to chew on. What we see is that we get 80% of the top 10. So 8 of those top 10 discuss porous material. So if you take a look at the results, I guarantee what you'll see is that they are all relevant to the query. And these are going to be the references that you're going to be happy that you saw. Even if Google didn't identify them as containing the concept of porous material, they are going to be relevant to the query. So let's take a look at our second test. The only difference between test 1 and test 2 is that we've increased the novel feature weight from medium to high. This puts more emphasis on that novel feature and should bring references that describe porosity to the top of the list. Let's see if that actually happened. So again, we have our abstract novel feature being the same, we have our short abstract, and we have our long abstract. If we look at the total of number of results, they're about the same, pretty consistent. The number of results that include a description of porous material increases slightly from what we saw in the original first test. The number in the top 10 is about the same for the abstract and novel feature and the short abstract. But when we look at the long abstract, what we see is that 100% of those top 10 results, so 10 out of 10 results, describe porosity. And again, we see an increase in the number of results that are being returned in the top 10 as well, moving up to 51. All right, so let's say we want to get even more specific and we really want to dig into this porosity concept. How do we do that? Okay, so we're going to go back to our project and we're going to click on the first high novel feature weight project. This will bring up our results page that we've already seen, and we're going to hit refine search. So if we look at refine search, we're going to scroll down, we're going to leave everything the same, and we're just going to scroll down to the bottom where we see facet terms. When we get to the facet terms, we're going to hit add a facet term, and we're going to simply type the phrase or the term porosity. We're going to hit next and run that search. Then we're going to go back and do the same thing for each of the other references. What adding a facet term does is it creates a Boolean query on top of the AI query that's happening. So we're providing a filter for specific terms. So any reference that describes porosity specifically, or any synonym of porosity, porous material, porous, etc., will be identified as being important to the search and returned at the top of the list. Again, our goal here is not necessarily to identify new references. We will, but mostly to get those relevant results we've already found that have a concept that we're super interested in to the top of the list, so we don't have to dig through thousands of results to find those important references. Those results have been returned and analyzed. Let's take a look. Okay, this table is set up exactly the same way. We have our abstract novel feature, our short abstract, and our long abstract. If we look at the number of results that contain a description of porosity, that number has definitely increased here because we've added that facet term. And if we look at the number of results in the top 10, we're also going to see that those increase a little bit, with our long abstract providing 10 out of 10 results from the top 10, basically the same as before. The difference is that the references that you see in that top 10 list are most definitely going to include a pretty solid description of the porosity of that material. Now let's compare just the long abstract. So if we look at a medium weight long abstract, we see the total number of results are the same. We get about 40 results that describe porous material and 80% of the top 10. If we look at the high novel feature weight, so in this case, all we've done is use that drop-down menu to move from medium to high, we see about the same number of total results with an increase in the number of results that describe porous material, and 10 out of 10 in the top 10 are describing that porous material. The same thing when we add a facet term. So we have a high novel feature weight. We're using the facet term porosity. We're seeing around the same number of total results with 62 now in even more references describing porous material. And again, 10 out of 10 of the top 10 and 52% of the overall results in the top 100 discussing porous material. So these comparisons show you the impact of novel feature weight and facet terms on a relatively basic query that we basically cut and pasted from an issued patent. You're probably asking yourself, so how does Google compare to this? And can we do that comparison? In fact, we can. For the Google searches, we use the exact same query that we use to identify the concepts. The only difference is here we've included the term porosity. The same goes for search B. The difference is that we've removed porosity from the main Boolean query and made it its own separate term. We then took those results and use the same process that we used for the Dorothy searches to identify references that discuss porous material. And then we're going to compare the results from those Google searches to the DorothyAI search, where we had a high novel feature weight and we used the term porosity. When we look at the number of returned results, Google returns many, many more results. The first search returned about 43,000, the second about 46,000. But when we look at the number of references that discuss porous material in detail out of those references, what we see is that the number of returned results are many fewer by comparison to the number that were returned in our DorothyAI search. If we look at DorothyAI search, what we see is 33% of those returned results discuss porous material in detail. In contrast, our Google searches are around 1.7 to 1.5%. Similarly, when we look at the top 10, our DorothyAI search returned 10 out of 10 or 100% of the top 10 results, whereas in both of our Google searches, we're below 100%. Moving on to the top 100, we see more of the Google results appearing in that top 100, but we don't know how on target those are in the context of the metal to air battery. Whereas we're quite certain that the top 100 from the DorothyAI search are all directed towards metal air batteries. And this is shown by looking for that source document. So we know the source document meets our search criteria. When we look at the DorothyAI search, we see that that source document appears number one in every single search that we did. In contrast, if we're looking for that result using Google, we're going to have to search through many, many records. So in the first search, it comes in at 8,300. The second did a little bit better at 645. Question is, how much time and effort do you want to put into finding results that are important to you? At DorothyAI, we've built a synergy between our AI and the user that allows the user to tailor the search, giving you broader, more expansive search, or a much more tailored and focused search by simply changing weighting. We've also given you the option to include facet terms, which layer a Boolean search on top of the AI-driven search that's happening in the background. All of these technologies get you where you want to be more quickly. Give us a try today. Follow the link below, and we will set you up with a free trial so you can give it a try yourself. If you have some results that you're interested in seeing analyzed the way we have here, feel free to shoot us an email with those results, and we'll let you know how your platform did. All right, thank you for watching, and have a great day.